Hello, hello. This is Postgres FM. I'm Nik, Postgres AI, and as usual here, Michael, PG Master. Hi, Michael.
Hi, Nick.
I proposed this topic because I thought we have a gap here. Before we started recording, you said we have already episode about transaction timeout, but it's very related, but it's not the same. So I wanted to dive deep into long-running transactions. What do you think?
Yeah, I was surprised we didn't have an episode on it specifically already. We had our first ever episode, didn't we, on slow queries and I guess long transactions as like part of that. But we hadn't done a specific episode on it, and I guess as a long-running podcast, maybe it's definitely time to revisit. Yeah.
Yeah, sometimes idle in podcasting. Yeah. So I would like to challenge us and think by the end of this recording, we record in advance as usual because some preparation is needed, post-processing is needed. Thank you for doing this, by the way. So I would like to challenge us and think, should this episode be called long-running transactions or somehow else? Because you already understand what I'm talking about, right?
Only because of our pre-discussion, I got a good hint from you. But is it more the problems they cause that you want to talk about, and therefore maybe it's only a subset of long-running transactions that are an issue?
So listeners who listen this already see the decision. Did we preserve a long-running transaction title originally, or we decided to change it? But the problem in my head is simple. I see in monitoring tools, in blog posts, in everywhere, everywhere actually, that long-running transactions are bad. And at the same time, I remember actually it was an interesting moment. I had an experimental educational course where I explained various concepts of database health. And we touched this topic, how long-running transactions are harmful to vacuum. And I said, you just open transaction and it will be blocking vacuum. And I said, it's so easy to demonstrate. Let's open a couple of PSQL sessions or something PSQL, vacuum verbose, and we will see it has that tuples but cannot clean up them because there is long-running transaction in progress. And I just wrote begin and it didn't work. It cleaned up tuples perfectly. I think I also tried again with begin and select, doing some select and keeping transaction open, being in idle transaction state according to PG set activity. And again, it didn't work. And I looked stupid. And the reason I look stupid is actually because we have actually two problems and we constantly mix them. And saying long-running transactions block vacuum is wrong. Not all of them block vacuum. Some of them block vacuum. And we have, in my mind, we should improve tooling and materials and everywhere understanding and start distinguishing two problems. One is lock-related and one is vacuum-related. We should change monitoring tools and like snippets, everything, to hunt two problems separately. To diagnose them.
Yeah. Should we go back to the basics though, in terms of maybe let's first cover the long-running transactions that are harmful or like can be harmful, and then reverse our way backwards to the ones that aren't, and therefore trying to distinguish between them.
Some people say long transactions, which I think is oversimplification because it may be very long but fast, or it may be very short but very long running.
Wait, what does long mean if it's not just about the time?
A lot of text.
Oh, sure, okay. I didn't even think about that.
I'm not a person who tries to be like pedantic and like I gave up. For example, my scientific mentor was distinguishing database systems and database and saying you cannot say Postgres is database. You must say like Postgres is database system or database management system. Like I already gave up. You cannot fight with all people. They will say it's a good database, meaning database system. So it's okay to say long transactions. It's not okay for my texts I write and like products we build. There we always pursue precision and we say long running transactions, right? But at a very high level, if you have long-running transactions, there are two dangers, at least. Actually, there are maybe a few more. But two main dangers are some locks are acquired, and as we know, like this is a simple rule to remember. We talked about this so many times. Locks are released only at the end of transaction. They cannot be released before rollback or commit. That's it. So it means that a transaction, if it lasts long, accumulates a lot of logs, and even excess share logs can be harmful, right? Sometimes.
Even if the statement that acquired the lock was short, if it's followed by statements that are slower,
lock is acquired. That's it. It will
exactly.
Lock is held until the very end of transaction. It might block someone like DDL. DDL might block other selects, right? As we also discussed many times. And this is a big surprise, and like this two-step effect which can put whole server down actually. This is a big deal. So if you just selected something and keep transaction open for long, you just, for example, should avoid changing schema, right? Or you have a dump happening. Very common situation. There's a dump happening or something like initialization of logical replica which lasts a couple of hours, for example. And at the same time we have deployment trying to change DDL. Trying to change schema, right? And this is a very dangerous situation because if you don't have lock timeout retries, we talked about it as well a lot. In these cases, can cause downtime. So lock acquisition plus holding these locks for long. This is danger number one. And danger number two is how MVCC in Postgres is organized. MVCC is multi-version concurrency control for like new folks. I know we have new folks all the time. And specifically vacuum problem. So to clean up dead tuples promptly, server should be in good state. And if you keep transaction long, in some cases, not in all, as we will discuss now, your long-running transaction it will block. If, for example, you inserted a row and just keep transaction open. This is a real transaction. It has real transaction ID, right? This is definitely will block vacuum, and it will need to skip the tuples which became dead recently after your transaction started. And this is global. This is the biggest surprise here for people, as I see, to realize this is global. You insert it to one table and keep transaction open. But vacuum cannot clean any table. It can clean only dead tuples which became dead before. Because Xmax, this is hidden column in every row. You can select Xmax from any table, right? Xmax for dead rows, it filled with transaction which deleted this row. With update or delete, it deleted this row version. And if this Xmax is in the past compared to your transaction ID, which holds this like snapshot, right? This will be possible to delete, but if it's later, Postgres thinks maybe your transaction will need it.
Yeah, it could still, if that transaction wants to read that row, let's say the one that got updated or deleted, it needs to return the old version. According to its snapshot. So it's still needed, or theoretically, potentially still needed.
It depends
so
also.
It's a feature, right?
Yeah. It's a feature, but also we need to think about transaction isolation levels here.
True.
Because by default, so if you have transaction ID, and so basically in Pgist activity, you can see the column backend Xmin, which defines this like horizon that your transaction needs, right? This snapshot, it defines this snapshot. Yeah. And if you have repeatable read transaction, which is not repeatable read, it's already higher isolation level. It's more like it's stricter. It's snapshot isolation, in fact, and it's not default, but it's used during things like dumping. PG dump will use a repeatable read. It opens transaction, repeatable read. And also logical replica initialization, and sometimes in multiple threads, multiple connections. So in this case, this snapshot needs to be held because this transaction, which is running in repeatable read, needs this snapshot for consistency. If all queries will need to read from this very snapshot. So all tables you read during dumping must be from the same moment, right? While in traditional, like default transaction isolation, which is read committed, it's shifting. Snapshot is shifting, so it's not being held. And if you, for example, open transaction, select from one table, select from another table, select from another table, you will see that this backend Xmin is shifting, right? Which means that our horizon is shifting and we're not blocking a vacuum like we could block if we are dumping or just using transaction at repeatable read. Which means that not all long-running transactions are harmful to vacuum, right? Does it make sense?
Yeah, at least from a bloat perspective. So actually, probably from everything in terms of vacuum, I was thinking there might be an exception around like transaction ID wraparound, for example, if we had a very long-running transaction. But if it didn't have a transaction ID, then actually that's not going to be an issue for transaction ID wraparound either.
That's an important distinction because if we sorted or we ran exceed current function or there's a new version, I'm constantly forgetting, I'm old. So you have allocated real exceed, it's one story. But if you're just reading and you don't have, your transaction doesn't have allocated exceed, it has only basically, there is concept of virtual exceed, which is optimization to save space because we have only 4-byte transaction IDs. Right, so it's not a lot these days, and if you like most of your queries, most of your transactions are reading transactions, it would be not wise to give them to consume from this space, right?
Yeah.
So there is optimization with virtual transaction ID, and purely reading transactions they only consume from that space, right? Virtual transaction IDs. So we don't have it, and which means that you need to distinguish these topics. And my point is that not all long-running transactions are harmful. But at the same time, if you're just reading, but this reading itself is still happening, you are reading from a huge table, it lasts long, definitely backend Xmin will be like some value not changing in just activity. In this transaction, reading transaction and read committed, it will be harmful. So I'm talking only about cases when we read something and we either read something else constantly, right? Small reads, right? Or we read and sit in idle transaction state, not doing anything and not closing this transaction.
Yeah. Are you is this a bit of an edge case? Like who's actually doing this a lot? Like when does it happen?
What exactly?
Like a small read and it doesn't get committed for...
Oh, it happens all the time. The number one reason is humans. So they...
Like opening an editor or something.
Yeah. In PSQL or even in more cases, some graphic interface, right? They begin some transaction, read something, and then they maybe change something also, right? More like usually when you are reading, you are not opening transaction. Like when you're just exploring stuff, you run some queries to understand the state of database. Usually you don't use begin commit transaction block. But when you try to write, sometimes you do. And abandoned transaction from humans, so common. It's very common. So just abandoned, forgot to close. In some cases, this is called turning off auto commit, right? So in some editors, you can say, okay, I don't like auto commit, I will turn it off. Then you start working but not committing, and then this is abandoned transaction. So it doesn't do anything. And if it holds this backend Xmin in PG's activity, this is what starts blocking auto vacuum. And in first maybe a few hours you won't notice.
So yes, I understand the dangerous case. I'm talking about the non-dangerous case. The opening a transaction, begin, then a select. You talked about just doing a read query, not doing an update. When would that happen?
In the same situation, it might happen as well. I was trying to understand all the possible cases.
Yeah.
In this case,
Well,
it's
no,
not
I think, yeah, but also I just don't think it happens in the same way. Like, I understand doing begin, update, and then you've got the option to roll back. If you're scared or you're traumatized maybe from doing an update once and then seeing, you're expecting one row updated and then you see 30,000 rows updated or something like that. Maybe you start using transactions explicitly so you can roll back.
I
Just
get
in
what
case.
you mean. Yeah.
But who's doing that for select queries? Like, I don't know.
Our purpose is to be complete, right? To cover all.
No, I
possible
understand. So
scenarios.
this is why I'm asking, is this an edge case?
Yeah, usually I think if I have a bunch of selects and I combine them to transaction, I would probably use repeatable read, so all of them are consistent. That's why I combine them, right? This is like basically like pgdump does, right? If I use transaction and I don't use repeatable read, why do I use transaction in the first place? In this case, if it's just a bunch of selects, maybe to like what comes to my mind, maybe to make sure schema won't be changed, to block DDL.
Or to do with the pooler, maybe, like to make sure you stay with the same.
Yeah, backend
connection.
maybe there might be some cases, and another very common situation when we see. So there is this term Xmin horizon, right? You can see it in some places in source code. You won't be able to see it. I think you won't be able to see it in documentation. I checked long ago. I think it's very like unofficial term. You can see it in some blog posts, but again, I feel it's not fully understood topic, right? So what is Xmin horizon? And I was trying to understand like all aspects of it, how to properly measure. And my question is like, why is not properly measured by monitoring tools? Because it's not. You like check all popular monitoring tools, excluding Postgres AI monitoring tool, right? And you won't be able to see they talk. Okay, there is a long-running transaction lasting like this amount of time. Okay, have you excluded transactions which are not harmful, or you included them? What's the purpose of this chart? Are we talking about danger related to locking, or are we talking about danger related to vacuuming? Unclear. My point is, if we start distinguishing, if we start thinking about Xmin horizon, we need to understand what it is and how to measure it, how to properly understand it. So I came up with the idea, we have 4 sources. First is PGS activity, backend Xmin. We just select like the oldest, right? Actually, you can use function age to backend Xmin, which will give you difference, just like integer difference between your current
very cool.
transaction. Yeah. This function should understand that we have wraparound of the space, right? So it will give you a number of transactions, the agent in terms of number of transactions, not in terms of seconds, right? The second, very, very common situation, super common. You created logical slot and either haven't started using it or abandoned or it's lagging. So if you check PG replication slots, it also has a column, it's called Xmin there, Xmin. And you also can use age. So it's another very popular reason to have something lagging. And we need to distinguish logical replication and physical replication, because as I remember, if you have physical replication slot but haven't started using it, I think it's not harmful. I might be mistaken. Logical replication slots are definitely harmful. Unused logical replication slots, definitely harmful.
Did this change? I feel like did this change in a recent version where I think there might be some new setting where by default they expire after a certain age of not being used.
Yeah, there is such setting. It's just a protection mechanism, and I think we should talk about protection measures separately.
Yes.
Right?
Okay.
Right?
Cool.
I'm just trying to say that physical and logical replication basically streams, they are slightly different here. Definitely, if you have logical, if it's unused, it's harmful. If it's lagging, it's also harmful.
Makes sense.
If it starts harming you right when it's created. So you don't want logical replication slot to be unused or lagging too much. Physical, slightly different. And I think, if I'm not mistaken, if you just create a slot but nothing connected to it, it won't hold Xmin horizon. Moreover, if you have physical replication, but this replication is not using hot standby feedback, on replica it's set to off, which is actually not common. Usually people prefer to set it to on. Hot standby feedback sends, for physical replication, it sends to the primary the information which Xmin Horizon is needed on replica, right? On standby. If it's not sending, it's better, right? Because we don't care. But this will give you like physical replica which will start lagging every time it has a long-running transaction on its own. While hot standby feedback will protect replication lag, but if there is long-running transaction on replica, it will report to the primary, and we will have the same effect as we had the long-running transaction on our primary, which explains why this dilemma makes it's really hard to have long-running transactions for analytical purposes on regular physical nodes, right? And you cannot offload it to replicas. Only if you can afford replicas which are lagging for hours, for example. Anyway, we have logical and physical replication which can also affect us, and we have fourth component, which is prepared transactions. There is a PG prepared XACTs transactions. A system view you can see also, I don't remember column name, maybe transaction or something, I don't remember. But you can also get, if you use 2PC, right, prepared transactions, in this case you have them, right? In this case, some of them might be affecting, they may affect Xmin Horizon. So I found four sources for our analysis to define which. So we dig information from all of them, take edges, and then just take the greatest of edges. There is such function greatest, right?
Yeah.
And this will be our true age of our Xmin Horizon. What is big, what is small? This is hard to understand. When I think about it, what is big? Is 1,000 too much, or 1 million too much, or 1 billion too much? Billion is definitely too much because we our
halfway there.
Yeah. We have 2.1 is basically the whole capacity for XID wraparound, right? But also there's also multi-exact mechanism additionally, but let's not go there. Billion is definitely too much. Is 1 million too much? In heavily loaded systems, I like to think about it like thinking about what tables we have and how many rows they have, and how many rows we consider, how many dead tuples, so dead row versions, how many of them we consider too much. Usually, we prefer for all TP, heavily loaded systems, we prefer to make AutoVacuum be very aggressive.
Yeah.
Default settings for AutoVacuum scale factor, AutoVacuum insert scale factor, analyze scale, they are like 10 and 20%. These are two common default numbers. It's too much. If we have 10, 100 billion rows, 10% is way too much. So we usually set, okay, like 1%, so 0.01, or even 0.5%. Sometimes even go even lower. And make it delete the tuples more often. Now you already have some hint. Okay, you think I have like 10 million row table, and I have 1% scale factor. It means that 100,000 rows is when AutoVacuum should start cleaning up. And then I think,
a good point.
Xmin Horizon is lagging that much. Okay, is it lagging 1,000? It's okay. We don't care. Our basically actual Horizon when AutoVacuum starts, we expect work from it, 100,000, roughly. But the problem is that we have different tables, small, big, right? So we need to think about core tables and nature of our database to think how much of Xmin Horizon, Xmin age, is too much for us, right?
I think there's two. You're talking almost like a bottoms-up approach, right? Working out how much bloat we can tolerate. But there's also
how much dead tuples we can tolerate. It's not yet bloat, as we remember.
True.
We allow too many dead tuples, AutoVacuum is converter of dead tuples to bloat. It will come and convert our millions of dead tuples to bloat, but it's not bloat yet. At least in my terminology, I wish we had official terminology for bloat. And for dead tuples, it's clear, but for bloat, we don't have it as well. In documentation,
but it also,
we won't find it.
The more dead tuples we leave around, the worse bloat issues can get. Like in terms of like fragmented indexes, for example, in terms of hot updates. If we've got dead tuples that we can't
might
remove,
benefit from it, but okay. It's why hot updates might benefit from bloat because they have space.
No, because it's not space yet. If you can't reclaim it, if it's not being processed by
But
yet,
then eventually vacuum will happen and
eventually,
it will leave a lot of gaps, and these gaps might be reused, right? So it's like
maybe, yeah.
There are opposite direction of effects here, right? So,
but the point I was trying to get to was often people are monitoring this in order to prevent transaction ID wraparound. So the top-down approach could be how much time. Okay, 1 million might not be that bad in terms of getting towards 2 billion, but if 2 billion could accumulate within an hour or two, if you've got like a ridiculously, so actually you might want an earlier alert or a lower threshold, because as soon as you find out that it's going above a healthy number or above like a not normal number for your system, you're on a stopwatch. You've only got 2 hours. You've got to fix this problem. So it might be that you're thinking in terms of top down as well.
Yeah. For example, if I see age of this is 100 million, it's already, wow, it's a lot. It's already like emergency.
You might only, exactly. You might only have a couple of hours at that point.
Yeah, speed is interesting. I wish we had also good, again, monitoring systems lack proper seed consumption, seed growth rate metric to be covered properly. If you think, okay, this is my Xmin horizon, some numbers. Okay, I know it's transaction, but you're right. It's hard to map it to real time. But here I see, okay, we consume 2 billion transactions per week. Oh, it's quite loaded database, in fact, right?
Yeah.
Real transaction IDs. In this case, I see peaks when there are busy hours. I understand my seed growth rate, and this is helpful for me. I understand, okay, I can already start playing with this. I think we could go even deeper. I just don't see proper analysis tools in this area developed. Like this is like my thoughts and from people I work with and talk to, and I see huge potential here. So it could be much better visualized, presented for analysis.
And as you say, separated out in terms of ones that like things that are risky in terms of locks and things that are risky in terms of
locks are completely
I'm going to keep saying
area.
bloat. Yeah. But that's what I mean. You're talking about different alerts, different charts, different.
Yes.
Yeah.
So I would have alert, and we actually do have alerts for Xmin Horizon based on understanding of this particular system with its growth rate and like table sizes, right? And behavior of vacuum, auto vacuum. And we set it, for example, I think 100 million is a huge number. We should set it lower and already start investigating what blocks our Xmin horizon. And this is the right direction to understand. And we also can check logs. If you enable auto vacuum, we usually aim to enable, if not all, but at least like above 1 second auto vacuum processing. So a log auto vacuum mean duration 1 second.
Yeah, it's great.
Sometimes we set to 0. Yeah, there is some risk that you might see a lot of and have observer effect, but usually like at least 1 second is beneficial. So you start again. I think all default was 10 minutes. It's ridiculously huge. Like you don't see a lot. And I think it was decreased recently, right?
Oh, cool.
Yeah. So what I'm talking about here, if you have a logging for auto vacuum behavior, it reports like Xmin horizon, it reports it, right? Transaction ID was this, Xmin horizon was that. It's this number behind. So you might extract information from those logs. And also it reports how many the tuples it would remove but couldn't because Xmin horizon is blocking. So auto vacuum messages and logs are extremely helpful for this type of risk analysis.
I think it might be.
Yeah.
I think it's still 10 minutes.
Maybe.
Wow. All right.
So this is about Xmin and vacuum behavior, Xmin horizon, and this concept. Again, like I think documentation could be fair that these concepts exist. Maybe like one should propose to define this because everyone suffers from bloat, and I think, in my opinion, everyone needs to understand, working with Postgres deeply enough, like it needs to understand the concept of Xmin horizon and to start distinguishing it from long-running transactions, right? And the second problem, first problem historically, lock acquisition. What to say about it? So it's, yeah.
I think we should point people. I think we did a good episode on that specifically. But yeah, maybe that's a good excuse to switch over to mitigations, though, because
mitigation. Yeah, just one point. Like, I wanted to mention there are some exotic problems also which might happen from long-running transactions.
Oh yeah, sure.
I point to my sub-transactions post explaining 4 problems with sub-transactions, and one of them which happened to GitLab, and we had an episode I think about it, right? So it was the most interesting. It was happening when you have long-running transaction. I think when you actually hold this Xmin horizon on the primary hold snapshot, or maybe logs. This is a question actually. I have some homework to do to return to that material and understand what of 2 problems happened there. So long-running transactions on the primary and high TPS replica started to suffer at some point because of sub-transactions. Once you closed long-running transaction on the primary, suffering ends. So this is exotic already. Exotic problems where I need to understand, is it lock-related or snapshot-related?
I also think replicas are an interesting thing in general in terms of long-running transactions. So long-running transactions on the primary and whether they affect the replica, and then also long-running transactions on the replicas and even when they can affect the primary.
Long-running transactions on replica, if hosted by feedback is turned on, as we discussed,
exactly.
They will report to primary, can have same effect.
Yeah. So I think that's not always something people are aware of. But yeah, in terms of mitigations though, it feels like timeouts are our friends in a lot of these cases. Is that, and monitoring, we've brought up monitoring a lot, right? Monitoring, alerting, even in extreme cases, killing certain problematic long-running transactions. What did you want to talk about in terms of mitigations?
So, yeah, of course, if you can get rid of all long-running transactions, both dangers don't affect your database health, which is great. But sometimes we need long-running transactions. Sometimes we need we need to accept some lag in replication slots. By the way, this what caused me to start distinguishing something is not right. We talk about long-running transactions, but the same problem, vacuum being blocked, vacuum not fully blocked, you understand, so you cannot delete some dead tuples.
Yeah.
It's not only about long-running transactions, it's also about slots, it's also about prepared transactions. What's happening? Okay, prepared transactions, they are at least transactions, but slots, right, or replication, like anyway, hot standby feedback. Okay, hot standby feedback is also about transactions, they just happen on standby, but just unused logical slot. So it's a wrong explanation of some problem. Problem is Xmin horizon is frozen. It's not progressing, right?
Not progressing, yeah.
Maybe it's progressing, but too slow also might happen. Yeah, so...
if it's progressing slowly, though, it's just blocked at a new point, right? Like, it's...
Yeah, if it's progressing too slow and your horizon of XSEED, not horizon, but actual XSEED is already too far. So basically what we should look at is age of Xmin horizon. Age of the oldest Xmin needed.
Yeah.
Yeah, this is what all we need. And if it's too far in the past, this is a problem. And reasons of this, as I said, 4 reasons. And mitigation is simple. Don't allow it to be too far in the past. How? First of all, in OLTP, I'm like very highly recommend to be very aggressive in with timeout settings globally. I know documentation says it's controversial and so on. If HTTP server setting can afford 30 seconds or 60 seconds as maximum for all OLTP requests, why do we database cannot afford at least the same for all regular traffic? Of course, for create index concurrently, reindex index concurrently, we need to set it to 0. What to set? Statement timeout and 2 other things, right? If you think about transaction, it might be like something is running, idle transaction. Something is running, statement, idle transaction. So it's either statement or idle transaction, and there is a whole transaction. So basically we have whole and two phases, like they switch after each other, right? It means we can limit the whole transaction or statement or idle transaction state. And for all three, we have setting, right? And transaction timeout.
Only since recently, though.
Yeah.
Only since version 17.
Yeah, we had episode about transaction timeout because it was my idea. I was super surprised. I was walking around thinking, why it doesn't exist? Like maybe I don't understand Postgres enough after 15 years of experience. Then I told it to Andrei Borodin, and he implemented. Great. In Postgres 17, it exists. So in all new Postgres, we have transaction timeout, so we can finally limit the whole thing. Because before, we could limit only statement and idle transaction session timeout.
Yes.
And if you have a series of brief statements and brief like waiting periods between statements, you could have hour or day-long transaction easily. Now you can limit the whole thing. And limiting the whole thing is helpful. Unfortunately, we cannot limit what we actually would like to limit is Xmin horizon. Maybe we should have. I just came. This idea came to my mind just now. Honestly, I need to admit. We could have like probably like Xmin horizon maximum, after which we start abandoning like we canceling transaction, abandoning prepared transactions, like deleting them, and maybe killing some replication.
Yeah.
Why not? Like 100 million protection, ultimate protection mechanism. And in this case, you don't need to map what's happening with your like server in terms of seconds and actual problem, like how many transactions you don't want to lag, right? For your garbage collection. Garbage collection is a vacuum, right? So maybe we should have those settings, maybe too much settings at the same time, but it would be flexible. I would say 100 million is my maximum, or 10 million is my maximum, regardless of
Even if Postgres shipped with conservative defaults there, it would be fine. Like, even if it was like 100 million as a default, it would be fine for like cases, wouldn't it?
I'm curious, maybe this idea was discussed, maybe it's not a good idea. To my mind, it just came, it's interesting. If you have opinion listening to us, leave this opinion as a comment under YouTube or somewhere, or like on Twitter or LinkedIn, I don't know. Anyway, this is interesting. But what we can do, we can protect with transaction timeout, statement timeout, idle transaction timeout. What else? We must actually monitor lags of replication slots, especially logical replication, but physical as well if we use hosted by feedback. And we should not allow lagging too much. And finally, we should be very careful with 2PC and abandoned prepared transactions. That's it. So only these 4 areas.
Yeah, when you say monitoring, you mean alerting as well, right? Like a
so if some replication slot is unused, logical replication slot, or it's lagging too much, again, this is interesting. It will be also either in bytes or in seconds. We should think about seconds, how much, how we need to map it to transactions, so understanding our seed growth rate. So there are different metrics in play here. So to understand health properly, it takes time. And if you have cattle, not pets, so you should have simple rules. If some slot is lagging too much, by the way, slot lagging too much, it's in bytes, right? We cannot limit it in seconds of lag.
Good point.
So there are bytes, seconds, and then exceed like number of transactions. So 3 metrics. There is a triangle here. Interesting. Anyway, this is to protect from affecting vacuum. You can also like reactively just monitor what auto vacuum reports in logs, and if it will start to complain clearly, right? So you can set threshold based on logs, and if you have some good log analysis system, you could set up alerts from there. And as for logs, for me it's very completely different topic. Like, long-running transactions contribute to it, but problems might happen very fast. Unlike Xmin horizon being blocked, you might not notice it at all. Even you blocked it for many, many hours. Maybe it was not. Maybe it was needed at just one time. It won't affect you so much. And the negative effects, they are not like they are postponed and they grow like it's not a cliff. It's like it's slow degradation. Unlike situation with logs it might be very fast. So if you have, as I said, the classic example is you have the weakest heavyweight lock possible, access share lock on table. You block DDL, DDL blocks other selects. Boom. What to do here? We need to use proper DDL deployments. We need a low lock timeout and retries. This is number one thing I would recommend. And number two thing is to craft schema changes properly to avoid long-running exclusive locks, first of all, but also access share locks as well at some point. They are not harmful unless you have conflicting sessions. And to detect conflicts sooner is helpful. Another measure, which is actually a common problem with Postgres, if we have vacuum which blocks us, vacuum always blocks us when we do DDL. We cannot acquire access exclusive lock on the table to change its schema if vacuum is happening. But fortunately, in most cases, vacuum is running in normal state and it will kill itself after, I think, a second.
Do you mean auto vacuum, or you mean anti-wrap? You mean not an anti-wraparound?
Yeah, okay, I'm talking about auto vacuum. Good correction.
Sure. Yeah.
Right. But if it's running in transaction ID wraparound prevention mode, which happens often if you have high XID growth, related topics, right? If we'll insert a lot, not in batches but single rows, for example, we consume XID so much, save points can contribute to XID consumption and XID growth rates a lot. In this case, we probably have a problem like if XID growth is high, auto vacuum transaction ID wraparound happens more often. It might happen, for example, every 2 days in the very busy systems. In this case, if it happens every 2 days, but we aim to have deployments 5 times per day, we are very rapidly developed startup. In this case, this might clash. You have auto vacuum transaction ID wraparound prevention, and you try to deploy DDL. And even if you have retries, you must have low lock timeout and retries. You try to deploy it, but it runs on your terabyte size table and blocks you. This is super annoying. You cannot deploy something you would need to deploy right now. What to do about it? Question is open.
Well, you've talked a lot about partitioning, so so the tables are smaller and the vacuums are quicker.
Yes.
But I actually also think, at the time I thought it was a good thing, but I thought the threshold where an anti-wraparound vacuum kicks in is relatively low in the grand scheme of things in terms of the risk. I would seriously consider, if it's happening every 2 days, it seems like a bad smell to me. That feels like something that shouldn't be. Let's make sure normal vacuum happens enough so that it doesn't have to run in anti-wraparound mode. I'm not
against this. It's good that it's happening often, and freezing is good. So partitioning is helpful not only because tables are smaller, but more pages are all frozen and we don't touch them anymore because they are our archive. And this is super. It makes things much more efficient compared to huge unpartitioned table where anytime page can receive new tuple, and it's not all frozen anymore in visibility map, right? The visibility map has 2 bits, all frozen and all visible. And boom, we need to take care. Auto vacuum needs to take care of this page again. So the problem is, for me, is not that it's too often happening. The problem is this threshold. I would sometimes. So it's okay to have it low and make it very frequent, good. Partitioning is great. But sometimes I wish it would be easier to raise this bar temporarily while I'm doing my changes. And then raise it back. But as far as I remember, I might be mistaken here. Last time I checked this maybe a couple of years ago, this topic. It's not so easy. You cannot change it globally so easy. It requires restart, I think. Maybe I'm mistaken again. And at table level, there is also some caveat. I don't remember which, but I didn't see a good way to... Okay, for each deployment, we want... And also interesting, you kill that vacuum which runs in transaction ID wraparound, and if you don't acquire lock on the table fast enough, it will kick in again. Especially, it might kick in if you have many workers and nap time is low, so it's an interesting problem as well. So raising this is quite it was not easy as I remember. So I came up with 2 ideas. first idea is if this is deployment, which is big deployment, we have like major upgrade or something, because it's a problem during major upgrades. We had it during major upgrades when AutoVacuum running transaction ID wraparound was a problem for us, or some major changes. If it's a like rare change, we probably should forecast when AutoVacuum will start freezing and do it before.
I like that. Yes,
Do it
yes.
before. Another thing is that probably we should just sometimes kill it ourselves, but if you want to kill it, you need to do it properly. You need to issue attempt to acquire lock on your table to change and kill it and immediately. Kill AutoVacuum and your attempt to acquire lock is successful, and then good luck to try to prevent transaction ID wraparound while we're doing our job. This is like
Wait, is that so that it doesn't start again?
Yeah. So
Okay.
I
That's
win. I
fine.
won. So that's it. So the lock is mine, and I'm doing my job. It's like it feels slightly dirty, right? But there's no harm if you also monitor exceed and multi-exceed wraparound risks. If you know you're only at 10% of capacity, 200 million, it's fine to go to 300-400 million during like even big deployment. You will be fine afterwards, right? So this feels dirty, honestly, to do this trick. I did this trick manually a few times in my career because I needed to finish deployment, and I knew that we are not in danger zone. So,
yeah, that makes loads of sense to me. My preference, I think, still would be avoid it happening as often as that, and actually trying to make sure things got frozen before it was needed. So it really is a fail-safe rather than a normal thing that happens in normal operation. But yeah, super interesting. We started the episode talking about what we should call it.
Yeah.
And I think maybe we should end it like with what do you think now, having talked about it?
Yeah. But we try to keep titles very short, right? We didn't have Xmin Horizon episode. I tend to think this should be called Xmin Horizon episode because this is where we spend time most. And it's less about logs, it's less like, and I think long-running transaction is a wrong concept to chase. You know?
Yeah, let's call it Xmin Horizon because I think that's going to be...
let's call it Xmin Horizon.
Yeah.
But my concern is that people think in terms of long-running transactions and...
So that's fine. I think long-running transactions is interesting, and I actually don't mind that there's this edge case of long-running transactions that aren't harmful.
Let's keep long-running transactions because it's easier to understand what we talk about. This is what people expect. Let's keep the name long-running transactions. Xmin Horizon, this concept is still, it's not fully clear in my head. It's clear, but I want it to become official in documentation. Maybe it should be explained in documentation.
And then that opens us up so we can still do an episode on that at some point.
Yeah. Maybe I missed some parts of it, how to properly monitor. I know some people who develop observability tooling listen to our episodes.
Cool.
Yeah, I hope it will be improved.
Nice.
It's like clarity. And I thank you for listening to this. I feel I went quite deep. We went quite deep in this episode.
I personally enjoyed it. Yeah, I hope everyone else did too. And yeah, let us know.
Great.
Nice one.
It was great to chat to you, as usual.
Likewise, Nick, take care and see you next time.
Yeah, bye.